Hi everyone! Here is part 2 of our U-sub with Trig video. And so what we're looking at here, our second case, is when you have multiple trig functions. Okay? I think one of the exceptions to this will be if you're looking at a combination of secant tangent. A secant tangent combination is one whose antiderivative is just secant. Okay? But the other combinations, like we see here, combinations of sines and cosines, typically that would mean that one of those functions needs to be u, and the other function will be a part of the du. In some problems, it actually will work either way. In other problems, it's very specific based on having one of your trig functions raised to a power. Okay. Anything raised to a power, it's very likely that the inside is going to be your u. Okay, so let's look at a couple of these examples. Okay. And I'm going to show you how they can work. In some cases, they can work more than one way. So 12 and 14 are both similar in that we have a sine function, we have a cosine function, and they are the same power. So in both of these problems, it actually does not matter whether u is the sine or u is the cosine. Okay. So let me show you on number 12 kind of what I mean about that. If I decide that u is going to be sine of x, that would mean that du would be cosine x dx, and our rewrite would look something like that. Now, always remember, we still have to do the antiderivative. So this is going to be u squared over 2 plus c, or we can make this 1/2 sine x quantity squared plus c. That's one possible approach to that problem. A second approach, do my little screen capture toolbar. If I take the exact same problem and I let u be cosine x, which would mean that du, and this might be where we want to write our little chart, sine, cosine, negative sine, negative cosine, sine. If I'm starting with a cosine and I'm taking the derivative would be negative sine x dx. You'll see I don't have exactly a perfect match, but I can move the -1 essentially over to be with the du. So I would have a negative du and a u. The cosine is acting as my u. Sine x dx is my du as long as I put a negative there. So then this would be negative u squared over 2 plus c, or negative 1/2 cosine x squared plus c. Now, I know it feels like they're different answers. They technically are going to be the same. What makes them it's a little confusing though, how they're going to actually be the same, is the c in both of them is not equivalent. So when I wrote this is my answer for number 12, and somebody else who would write this as their answer for number 12, the c values would be completely different. Okay. If it's a free response question, it absolutely does not matter. Either one would be appropriate. If it's a multiple choice question, you often then would have to figure out which way they did it to find the right answer. However, I doubt that they would probably make this a multiple choice question because it does have options. And if it were a multiple choice question, they may ask you, they may give you a little direction, say, given that u is this, what would the antiderivative be? Now, when you've got slightly more complicated expressions, like when u is sine 3 theta, as we have on number 14, which would be one way to approach that, you have to remember that the du would be cosine 3 theta times 3 with a little bit, because of a little bit of chain rule. So we will need a 1/3 with my du to make the substitution work. Okay. So you've got to watch for that. Depending on what your u looks like, your du may include a chain rule in these problems. Now, 12 and 14, you've got a couple options. For 13, 15, 16, and 17, it's important where you have to pick the trig that's being raised to the power. Now, your u is still just the single trig function, not the entire trig function and the power. Okay. Du would be negative sine x dx. And so then the rewriting on this problem, I would have du, and I would have, I'm going to write it as u to the negative 2, because it would be 1 over u squared. And then I have to do my antiderivative. And you can see I'm not finishing these. These are all worked out for you on the key. So part of your responsibility will be to go through using what we just talked about in these multiple trig function problems and see if you can choose the right u, do the substitution, and work backwards. When you have multiple trig functions, the interesting thing is your antiderivative process doesn't end up involving trig. Like when I write the antiderivative of u to the negative 2, right? So let's just go along with this one. Okay, my antiderivative is u to the negative 1 divided by negative 1 plus c. Let me go back for a minute. So what u was sine of 3 theta, u sine 3 theta. Oh, and I needed the 1/3 there, didn't I? Yeah. Oh, no, this was, I'm sorry, that was number 13. I got confused. I'm looking, so this was number 13. No 3. No 1/3. That was for number 14. Oops. Oops. No 1/3. Okay. So let me go back to look at number 12. So u was cosine in this case. Right? So u is cosine theta. My antiderivative process doesn't involve any trig. However, when I go back to the original function, I'm going to get a trig answer, and that might mean there might be an identity at play, ultimately, to choose the right answer. Okay. So that could be an extra issue as well. The antiderivative part, or the rewriting, is one issue, and then rewriting after you've taken your antiderivative, possibly having to use a trig identity to ultimately get to a simplified answer, that would definitely be a challenge if you were looking at a multiple choice problem. If this were not a multiple choice problem, this answer right here that I'm putting the box around would be absolutely fine. However, if it were a multiple choice problem, it may be that that choice is not available. This might be the choice you're looking for. So within this packet, you've got, after the first set of problems, you've got u subs that involve u as a trig function. You can see you've got some definite integrals here. So this is where we're going to change everything, including the shoes. And then number 21, and then some additional practice as well. Okay. So your responsibility over this first week of January is to work on this u substitution with Trig.